Hello everyone, welcome back to the Model Context Protocol video series. So as a quick recap, over the last few videos we have been exploring MCP servers. We started off with tools and resources, then we started with MCP clients. We also looked into LLM agents, how we can build LLM agents which can connect to the MCP server using MCP clients, and then finally connect to the application layer, which in our case has been the MSSQL database. We also worked a bit with prompts. We added a prompt. We did A/B tests to see if that actually helps our server. We were able to more or less determine that it does. And then in the last video specifically, we talked about the challenges we face when combining an LLM agent with MCP, because while MCP has been designed keeping LLMs in mind, our current LLM SDKs that are available are not really configured to be used with MCPs, in the sense that they only understand function calling tools, in the sense of like, yeah, I have a set of tools which are a set of functions I have, and as per certain user prompts I can call one of these tools, but it does not understand that there are resources, tools and prompts from the perspective of MCP. So in the last video, we tried to solve this by semantically adding by semantic approach, where we added a tag tools underscore resources underscore prompts underscore. So sorry, before that, we also saw like how as a workaround we have to convert MCP server tools resources prompts into LLM tools. For MCP-use, we're using LangChain adapter to do that, and then these LLM tools are all fed in as the tool calling tools for the LLM agent. But yeah, as I was saying, this process basically does not allow the LLM to understand that instead of having a set of tool calls, it actually has tool calls of three unique types: resources, tools and prompts. And so that's what we tried to do in our last video. We tried to make sure that the agent understood this, and what we did was we adopted a semantic approach where we added a tag, either tools underscore resources underscore prompts underscore, to the LLM tool, based off whether it was converted from an MCP server prompt, resource or tool by LangChain before it was fed into the agent as an agent tool. And then in the system prompt, as we had seen last time, we basically told it that we basically made the agent understand what resources, prompts and tools are, and we'll probably see that again today in one of our agents, and gave it the understanding of how to use these prompts, tools and resources. And once we had this in place, the biggest improvement that we observed was the flow that the agent started following. It started following an ideal flow where it would first always hit the prompt, get an understanding of how to do the workflow. Then it would always hit the resources, and it would get additional context to start before it would try to come up with the SQL query. And then finally it would come up with the SQL query and then try to execute the SQL query, which is what we expect when we are working with an MCP server, and not the previous behavior where it was doing it in a haphazard manner, in a try and error basis and so on and so forth. So now that we have an ideal system in place, we want to start comparing it with some industry standard MCP servers. And the industry standard MCP server we'll be choosing for this is the one developed by Microsoft. I'll try to attach the Microsoft Git repo link as well, which contains the code for the MSSQL MCP servers that they develop. But essentially they have two versions. One is a Node version and the other is a .NET version. We'll be working with the .NET version here. So as you can see, I already have the MCP server here copied over, the Microsoft's MCP.NET version. So just before we talk about any comparison stuff, the first thing we had to do, or rather I had to do, was I built a new test set. So the idea is, like, I have my own platform which is connecting to a database service, which is essentially connecting to the MSSQL database using the MCP server. And right now it's using the Microsoft MSSQL MCP server, right? And the idea is to figure out whether our custom Python MCP server is equivalent or better than the Microsoft MCP server, so that the Microsoft one can be replaced, the C# one can be replaced by the Python fast MCP server based MCP server. Now, before we can do this comparison, the first thing that I had to do was figure out what are some of the tools that the MSSQL MCP server, rather the C#, the Microsoft MCP server is using when it is trying to resolve the user prompts that we are passing in my platform, right? So I created a new test set for that. So first, let's quickly go over the test set. So just like before, it has the natural language. So it has 6 natural language prompts queries. 4 of them are marked as easy, 1 difficult, 1 very difficult. I believe they more or less encompass most of the query types that we are currently passing in the platform. So as you can see, like just like the test set before, it has a natural language prompt, which is the user prompt. It has an expected SQL query, which is what we expect should be run to get the correct data for that natural language prompt, to answer that natural language user prompt. And then we have the expected result field, which is obtained by running that expected SQL query against the MS SQL database instance to get that data, right? So I ran the Microsoft MCP server against this test set, against the prompts in this test set, to figure out what tools is it using. So if we look at the Microsoft MCP server here, we'll see that it actually has 7 tools, right? So we needed to figure out if it is using all these tools when answering the prompts that we have, or if it is using a certain subset of tools. The reason behind this is, like, in our custom MCP server, we obviously don't have all these tools, right? We have some of these functionalities. So we need to make sure that any functionality that the C# MCP server is using is not missing in our MCP server. So I did a few test runs, and essentially I found that the Microsoft MCP server, when answering our user prompts, is essentially using 3 unique tools out of the 7 available tools, namely read data, list tables, and describe table. Excuse me. So the read data is equivalent to our execute SQL query tool, where it actually executes a SQL query to read data from the database. List tables is equivalent to a schema/all resource, where it gets back a list of all the tables in the database. And describe table is equivalent to a schema/table name resource, where it gets back the schema details of a particular table in the database. So essentially, we have been able to determine, confirm that the features, the tools that are used by the Microsoft MCP server has been replicated in our Python MCP server as well, in either the form of a tool or a resource, right? So now what we can do is we can start the A/B test. So that's what we'll do. And just like in our previous cases, during the A/B test run, I'll fast forward the video just so that the entire video doesn't take too long. So let's start the A/B test. And before we start the A/B test, as the thing is working, let me quickly go walk you through the A/B test script. Where is it? Let's see, A/B tests here, right? So while this is working, let's quickly go over here. So as you all know, like usually we have this framework initialization, then run just like the A/B tests before, right? Like then we have the run cross-platform A/B test, and over here we'll have this single case function with either A or B, and then test single case for approach A will create the agent A, create approach A agent, and then for B it will create approach B agent. Now in our case, for this case, create approach A agent config, if you check the config details, you will see that it's the .NET MS SQL. So it's connected to the .NET MS SQL. This process is same. We are converting the tools. We have the LLM instance. This is the prompt. We are creating the agent with the LLM instance tools and prompts, and then we are setting some additional parameters, and that's it. Approach B is exactly the same thing. The only difference is that we have the Python MCP server in the config here, and we are also creating semantic tools. And as a result, we are also making sure that the LLM has an understanding of what resources, tools, and prompts are. That's the only difference. So yeah, for the rest of the test run, I'll fast forward. Let's start and we'll reconnect after the test is finished. Awesome. So our A/B test has finished running. So now, just like always, we'll first quickly create the HTML versions and then we'll go through the HTML reports to see what we can see, right? So let's run uv run python report gen. Let's see, report gen convert to report.py, and then for that C# AB console log, right? And then we have uv run python report gen. We have generate cross platform comparison HTML, and then we have the C# like the file itself, which is AB results, right? So we have the HTML reports created for both. So let's quickly try to open them up on the web browser. So I think this is the detailed one and this is the table view. So let's start first going through the table view, right? So the first test, we see that both were able to get the result. Agent B took lesser time. The second one, it was both got the result, but again the second agent B took slightly lesser time, more or less same time. The third one, both got result. The second one actually did not get the complete result, only got total sales revenue, whereas agent B was able to get total sales revenue and total COGS, which is what we expect, and it took lesser time. The fourth one, agent A was unable to get the result, agent B was able to get the result. Fifth one, both of them got the result. Agent B got some more detailed result and it took lesser time, but both of them got the result. And then for the sixth one, both MCPs got the result, but agent A took almost half the time that agent B took. So yeah, so just from this test result, we can see that one, agent B has been able to answer all the test queries, whereas agent A has failed at least one of them. I think test 4, yeah, it failed. And we also see, for example, in tests 2 and 3, agent A, or rather in test 3 and maybe test 5, I think. Yeah, test 5, agent B has been able to get more detailed information, which is what we are expecting, rather than agent A, which only gets a part of that information. And also we have seen that in general, agent B is taking lesser time. So just from this test run, we have been able to demonstrate that our MCP server, which has tools, resources, and prompts, is able to outperform in some ways the Microsoft MCP server, which has access to only tools. And that's what we are trying to figure out here. We are trying to see what's the behavioral difference between an MCP server that has access to prompts, tools, resources, in comparison to an MCP server that only has tools. Now, as I had said earlier, it is very important to do multiple test runs to get a complete picture. Now, this test run gave us some understanding, but to get an even better understanding, I had done 7 test runs before we did this video, right? And we can have a quick look here. These are all the 7 test runs. It's the exact same queries. So all 7 runs use the same set of queries, and we have the performances more or less recorded here. So I want us to go through some of these graphs that I have to get an even better understanding of the agent A versus agent B. And so I keep saying agent A versus agent B. Agent A is the C# MCP, which is Microsoft's, and then agent B is the Python fast MCP server, which we developed. So our agent B has access to resources, prompts, and tools, and agent A has only tools, right? So also just a quick explanation of the graphs. There are 6 graphs you can see here. Each of them correspond to one of the test queries. So the first one is test 1, how many customers, second is the test 2, third, and we are comparing it for the performances across 7 test runs, right? This is a time graph, so it's plotting the time. We also see crosses, so the crosses indicate cases where the agent was unable to get answers, correct answers, or successful answers. Or so just to give you some quick examples, for example, in the test 1 run, you will see that agent A was unable to get an answer for test 3 and test 4. Like here it said no records available, and here it said an error code 400. So if we look at the graphs for test 3, agent A was, as you can see, it's marked fail. Test 4, actually, if you look at the graph, and if you see the test run that we did right now as well, agent A has not been able to get data. So test 4, it seems that there is no record available. And if we go through all the, like even if we check the last test, if we see, we'll see that test 4, it still fails. Like here it comes up with a formula where it fails, and it took like almost a minute. Test 6, seems there are no records. In fact, today's test, like today, then when we ran the test again, test 6, or rather test 4, it again failed. It seems the query did not return any results. So agent A is consistently failing for this test, right? And then the last interesting thing I would like you to notice. So in general, before we talk about the interesting thing, in general, we can see that for all the queries, agent A agent B in general is quicker than agent A. Now there may be one outlier. For example, the first one in the 7th test run, agent B took more time. For the second query, agent B took more time in the 5th run, but that was also the time it actually failed. For the third one, agent B took more time only for the 6th test run. So there's, out of 7, there's only probably one time where agent B is taking more time or it's failing. Usually agent B always succeeds and takes lesser time than agent A. The one discrepancy or one challenge, one issue we see with agent B is for test run 6, which is a very, it's the most complicated prompt we have. In the test run that we did right now, we were able to see that it actually performed as expected. It was able to get the result, and it took, as I said, almost half the time than agent A. And you can see this reflected in the graph as well. In first test, it performed admirably, again, like almost half what agent A took. Second one, it failed. So second one failed. I'll just show you what I mean by fail here. It is basically agent stopped due to max iteration. So it's not really failing, but it is what's happening in this case. And like I have gone through all the detailed logs for these 3 cases, and what I have seen is that essentially what happens, it tries to execute a SQL query, but if it comes up with a SQL query which has wrong syntax, it obviously gets back a SQL error, right? But if it enters a loop trying to execute the same error in a SQL query again and again, keeps giving back the same error, it finds very hard to break off from that loop. And I think the reason is because it does not actually have proper direction what to do when it faces an error case. For example, in the prompt that we have in the guidance tool that we have, like the tool it's calling LLM tool call, or actually the prompt, like the MCP server prompt, we talk about how it is supposed to use the prompt itself first, and then we talk about how it is supposed to use the resources, and then to get additional context, and then we talk about how it is supposed to use the tools to actually execute the SQL query. But we do not talk about what to do when it faces an error when performing this tool call, this execute SQL query tool call. Specifically, we also did not give it any guidance what to do when it enters this loop where it tries to keep executing the same SQL query and faces the same error. So I believe adding some more details or more direction regarding this situation to the prompt, either on the MCP side or on the system prompt side, would definitely help with this. This is something that I will be trying to look to test in some of the next videos. Some of the other things that I also want to start looking into is MCP elicitation and sampling. Those are some of the newer MCP features. I just want to see how we can use them to further juice up our MCP servers. But I believe in general we have been able to achieve what I wanted to demo at the onset of this video, which is a MCP server which has access to tools, prompts, and resources will generally outperform and always has more potential than an MCP server that has access to only tools. I'll also quickly show you another graph, which is the success rate. So we already talked about what I mean by fails. So it either doesn't get back any data, or it, like the agent fails, or it faces an error, token limiter, or something. We see that out of the 7 test runs, agent B was able to successfully return results for all the user prompts 3 out of 7 times, and 4 out of 7 times it failed at least once. 3 out of them would be actually the last test case, and then once it failed, I believe the test 2 it failed once. And again, like the last test case, as I said, it's not really failing, it's just exceeding the time, which is why it is failing. It is entering the loop, it is unable to break off from that loop. And for agent A, we see that it fails 2 of its 6 user prompts 2 out of 7 times, and then the remaining 5 out of 7 times it fails at least once. And we already saw this, but it is always failing the test 4, right, where it says that it seems that there is no record when we actually know that there is data that can answer this question. So I think that is it for this video. Thank you for watching. Cheers, bye.